What's up, everyone? This is LeetCode 438. We're doing this in C++. We've done this in Python already. So we have to find all the anagrams in a string, right? We're given a string S, a string P, and we basically have to check if the anagram of P exists in S, okay? So, and if it does, we return the indices at this where the anagram starts, right? So for example, the reason this is 0, 6 is because at index 0, right, we have an anagram, right? CBA can be rearranged to get ABC. At index 6, we have 0, 1, 2, 3, 4, 5, 6. Right? We have BAC that can be rearranged to ABC, right? So we have two anagrams of P in S, right? So the problem statement should make sense. I don't think it's too complicated. Now, in terms of the solution, right, which is what we're going to get into, we're going to use a sliding window to approach this, right? Because you should kind of have a general idea that's probably something close to what we're going to do, because on the surface, right, it looks kind of like a substring type problem. Generally, you not always, but a lot of times you do use sliding window type solutions for these types of problems. So what we're going to do this is we're going to use a hash map, okay? And I'm going to draw this out just so it makes sense, right? I have this will be we'll create a hash map for this where the keys will be the letters and the frequencies will be the values, right? So these are all 1. Okay, now the way we're going to do this is we're going to basically traverse sequentially this input S or linearly, right? And we're going to kind of build out a hash map as well, right? So we're going to have a window initially of size 1 because we're only looking at C, and we're going to add C, right, with a value of 1. Okay, now we're going to look at this window size 2 because we're basically just doing a for loop. That's what I mean when I say we're going through this linearly, right? So when we get to this B, we're going to add that to our hash map as well, B equals to 1. Then we go to this A, right? We're going to add A to our hash map. Okay, now we have a thing now where the length so far is basically the same length of P, right? Right, these are the same size, right? So we're going to look at this. So we're going to look at if there's an anagram using basically the values, right? Right, if these two are equal, which they are, right? Because we have a C here, we have a C here, a B here, a B here, an A here, and a here. We're basically going to grab the starting index of this, which would be 0, right? And that would be put into our output. Okay, now we have another issue, which we're going to get into now, which is when we go to this E, now we have a window size of 4, right? So if we add this, an E here, right, we're going to have an issue. So what we're going to do when we get here is we're basically going to take this character, remove it from our hash map, or decrease it. The reason I say or is because there really is two edge cases. So let's say for some reason we had another C somewhere in here, right? We wouldn't want to remove the C from our hash map because, well, we would, like if this was a 2, we don't want to remove the C because we still want to look at one of those C's, right? But in this case, when it's equal to 1, we do want to remove it, right? You'll see that in the solution when I write up the code, but just keep in mind that whether you remove it or just decrease it kind of depends on what the actual value is. Okay, but we're gonna look at this E, right? But so because we want to add this E, but hey, we don't want to look at 4 characters. We want to look at 3. Why do we want to look at 3? Because the size of P is 3, right? So we're gonna remove C. Okay, and now we're gonna add E. Okay, which is what we should care about, right? Because we want to look for anagrams. Obviously this is size 3, so we want to look at substrings really that are size 3. Okay. So that's basically what we're doing. Okay. It's not too complicated, but it is a little tricky to understand at first. But I think you'll be okay. So we cannot make anagrams if the length of P is greater than the length of S. This is really just kind of like a base case, right? So we want to make sure we handle that. I actually tested this problem before recording. I think you actually do pass the test cases still, because there's only like 70 test cases or something for this problem. It's not that bad, but it's still good practice to do this because if you got this problem in an interview or something, you just want to account for all your edge cases. in interviews, obviously, you're always going to get a bunch of a very strange edge cases. So we want to make sure we handle that here just to make good habits, right? So again, we're going to create our hash maps, right? I'll just call it p map for p, and I'll call it s map for the s string. Okay. Okay, we're going to do that. So we're going to build out p map, which is equivalent to counter in Python. Maybe you don't use Python, but if you do, I'm just kind of explaining, giving context. So we're gonna say p map of c. No, we'll do plus plus. Okay. And here we're gonna say, well, we're just building out the hash map right now, right? Or up here we're just building out the hash map for p. Okay. For example, 1, right? That'd be just the 3 characters ABC. Okay. So here is basically where we're going to go through linearly string s. Okay, and then we'll do stuff as we go along. Okay, this is basically where the bulk of our work is going to happen. And before we do that, we need to create a vector called answer so we can actually return something, right? So we're going to say vector int answer, and let's actually return that at the very bottom, right? We're going to say return answer. Okay. Okay, here's where the bulk of our work is going to happen, basically, right? So we're going through length s sequentially, right? So we're basically going to do s map, right? S of I, right? We're going to add this to our hash map. Okay. The current character we're on, let's add it to our hash map. Okay. Now, we might have a case where we add that character to our hash map, and now our window size is actually 4. So if that's the case, we need to remove the leftmost character, right? So we're gonna check for that first by saying if I is greater than or equal to p.length, right? If that's the case, we're gonna say char left char. We're gonna say s of I minus p.length, right? Because let's say I is at 3, right? We'd be looking at the 4th character because I is the index, right? So if I is 3, we're looking at the 4th character. Sorry. So sorry, I'm getting a little confused. Let me draw this out. So let's say we're at C, B, A, and then we add E, right? So I should be at 0, 1, 2, 3. Okay. So when I is at 3, right, the leftmost character should be I minus the length of P, which is 3, right? So 3 minus 3 gives us 0. So as you can see, we're getting the leftmost character, right? I know I tripped up a little bit a few seconds ago, sorry. We're just grabbing the leftmost character because that's the one we want to remove from our hash map, right? So we're gonna say if s map left char, wherever it is, right? If that's equal to 1, we just want to remove it from our hash map. So we're going to say s map dot erase left char. Else s map. Maybe I am in I'll do that later. I just realized I am in Python, or sorry, I'm in C++. I shouldn't use underscores. We'll fix that after. Right, because if you have something like C, B, A, C, right? We don't want to remove C from our hash map, right? We just want to decrease it because we still want to have C in our hash map because we're looking at this window here. So we want C in our hash map. So we don't want to fully remove it. We just want to decrease it, right? That's why you basically have to do this check while you have this if else, right? So I hope that makes sense why we have that. Okay. So we're doing that. And I believe we're good. Now we can basically compare the hash maps, which is basically what the reason we compare the hash maps is we're just using the values from the p hash map and the s hash map. And if the values match, we know we can build an anagram, right? Because I mean that's kind of the whole point of using hash maps. Because if we have the same characters with the same values, then we know we can build an anagram because they can be rearranged in any way to basically make up each other, right? So we're going to say p map, s map, right? If that's the case, we're going to do answer dot push back I minus p dot length plus 1. Okay, I'll show you why we do plus 1, right? Just really quickly. So let's say we have CBA, right? So this would be 0, 1, 2, right? And I would be 2. So 2 minus 3, right? P dot length would be 3 because ABC length is 3, right? That'd give us -1. We don't want to push back index of -1. That makes no sense, right? So we have to add the 1 to basically offset it to the proper position to get the proper index, right? Okay, and I believe that should be it, unless I'm missing something. And what I am missing is we're going to actually you can call these hash maps whatever you want, really. It's kind of your decision what you want to call it. But I'm just gonna call it PMap and SMap. SMap, 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 SMap. Okay. I'm just renaming these because I don't want to use underscores because that is more of a C++ thing. You want to use as a Python thing. You use camel case in C++. So I'm just trying to be consistent, right? Believe we're good. Uh-oh. Forgot my colon. Silly me. Okay, and that should be it. Okay. We're basically, again, we're really just using a sliding window, and whenever we move the sliding window over, we want to basically remove or decrease the frequency of the leftmost character as we move along our window. At each step, we're basically comparing that hash map for that window to the hash map of the string P that we created, right? And if they are equal, we can make an anagram, right? It's not too complicated. Obviously, it is pretty difficult to come up with on your own. Or maybe it wasn't, I don't know. But for me, it was. Um, but I think the solution makes sense, right? But if you have any questions, you can ask, of course. Anyways, I hope this helped, and I'll see you guys in the next one. Peace out.